So I'm going to go through and explain some of these test corrections because you guys have been struggling quite a bit with providing me with the level of correction and explanation that I need. So here are just some examples of some frequently missed questions. So for example, if you look at the number 1, you have they divided by 3.0 times 10 to the 8th, which is an error. And then you can see when they're converting from meters to nanometers, they made a mistake. And then notice their final answer has 3 sig figs. So here's the correction I would make. First, you need to state what you did wrong. So my first mistake was that I forgot to convert the frequency from kilohertz to hertz, because if you notice it was 102.7 and I needed to convert to hertz first. So I must do that in order to use the speed of light formula to find wavelength. My next mistake was that when converting to nanometers, I accidentally put the unit for nanometers in the denominator instead of putting it in the numerator, which is needed in order to get into those units. Finally, my answer is 3 sig figs when it only should have 2, since the speed of light, 3.0 times 10 to the 8th, only has 2 significant figures. So I've clearly explained what I did wrong. Now I'm going to explain how to do it correctly. So to calculate the wavelength correctly, I should have converted 102.7 kilohertz to hertz. And I show that conversion right there. And then I show what I got. Then, using the speed of light formula, and I show the formula, divide both sides by my frequency, and the wavelength is 2.9 times 10 to the 3rd meters. Then I need to convert that into nanometers, and I show that conversion. And notice you can have the actual fraction, right, by putting insert, and you can insert an equation, right? So do that. I don't want to see some of what you guys have written is really hard to follow. This is pretty easy to follow. The only issue with the showing the fraction like I do there is I have to put the caret and the -9th. But then when I'm writing it out otherwise, I expect with exponents for you guys to write it as superscript. So like I did 2.9 times 10 to the 12th. That 12 is a superscript. If you need help doing that, please come and ask me. I'm tired of seeing people write it out, like literally write 10 raised to the power of 12. Don't write that. It doesn't look proper. That's not how we do it in science. You need to actually write it out properly. So please come to me and I can help you. Okay. This final answer has 2 sig figs, and I further explain why, since the fewest number of sig figs comes from the speed of light, right? Next is number 12 that a lot of people miss, okay? So if for number 12, I'm going to look at it really quickly. 12 asks you to find the element that has 5 electrons in the n equals 5 energy level. So a lot of people put NB, which is the wrong answer. So for my correction, I'm going to first explain why I put what I did. So I wrote NB because I assumed that the entire 5th row counted as the 5th principal energy level. However, since the D sublevel starts 1 principal energy level lower than S or P sublevels, I was incorrect. So I've explained what I did wrong. Half of the battle of this, the reason why I have you do test corrections, is for you to recognize what you did incorrectly. Don't just say I was wrong or I was stupid. That doesn't help. Get into your mind when you're taking the test. Why did you put what you put? Now let's address it. Okay, so the correct answer is SB, since the electron configuration for SB in the 5th principal energy level is 5s2, 4d10, 5p3. That gives 5 electrons in the 5th energy level. Okay, so I've clearly explained the correct answer. For number 15, a lot of people just said going from left to right, the atomic size gets smaller. And I didn't give credit for that because I know it does. Because I told you by telling you that, which element? By telling you that fluorine is smaller than oxygen, I told you that pattern. Okay, so instead so the correction would be, rather than explaining this trend, which the question asked me to do, I simply restated it. While the trend is helpful, I need to make sure I understand the reason for this trend. So that's me explaining what I did wrong, okay? Then I explain the trend. As you move from left to right across the periodic table, the number of protons an element has increases. As a result, electrons are more attracted to the nucleus, causing the size of the atom to decrease. Notice not only is my science correct, but I'm using proper grammar as well. Okay? It flows properly. You can understand it. Sometimes when you guys write, I honestly can't understand what you are saying. Okay? And I'll put a question mark and I'll take off. Okay? 16b, oxygen has a lower ionization energy because nitrogen is actually larger in size. So a lot of people struggled with this question. They put random answers. Okay? The correction is going to be, although I drew the correct orbital diagram, if you don't know why it is, because that was the hardest question on the test, I hadn't explained to you, this was the one question, one point that I wanted to see if people could think outside the box. Okay, so if you honestly didn't understand this question, for one question on the test, you can write this for your correction. I honestly didn't understand why oxygen would have a lower ionization energy. I'm fine with that. But then, to explain the correct answer, looking at this orbital diagram, I now see that the electron that is being removed is paired with another electron in the first 2p orbital. Since electrons repel each other, that makes it easier to remove that first electron, causing the ionization energy to be lower. That's the correct explanation. Okay. For 17, a lot of people, for like 17 and 18 and all of those, 17, A, B, C, D, a lot of people missed those. Okay, so let's look at an example correction. If you put Li, this question asks for the alkali metal with the lowest ionization energy. I put Li, which is incorrect because Li would actually have the highest ionization energy since it is the smallest alkali metal. Notice I am explaining what I was thinking on that test and making it clear. I now understand that my thinking was incorrect, and now I truly understand the question. So the correct answer is francium, since atoms increase in size moving down the periodic table, and they do because they have more principal energy levels. Francium is the largest alkali metal and therefore has the lowest ionization energy. Okay? For 18, a lot of people miss this. For example, if you put bromine, you could say, I said bromine because I thought an element with 7 valence electrons would have the greatest jump between the 6th and the 7th, for example. Okay, you put something, explain what you put and why you put it. Okay, the correct answer is SE. Removing valence electrons requires less energy than the other electrons, since other electrons are closer to the nucleus. You could also call those other electrons core electrons. Since SE has 6 valence electrons, it's relatively easy to remove the first 6, but then there's a big jump between the 6th and 7th ionization energies, since the 7th electron is in a lower principal energy level and therefore more difficult to remove. Okay? Notice these corrections, according to this, I didn't make that many mistakes on my test, but look how long my corrections are. Okay? What I found very ironic was for people who missed the fewest question on the test, their corrections were longer than the people who missed way more questions. Okay? If you miss a lot of questions on your test, your corrections should be 3 or 4 pages long, not one single page long. Okay? So I'm going to hold you to the level of the quality of correction that I've shown you here. If you want to have me check them before you turn them in, I'm happy to do that. But please do not waste my time turning in corrections. And when I'm reading them, it's clear you still don't understand the concept. You're wasting my time and you're wasting your time. Okay? So I've now showed you the level of correction that I expect from now on.